We're going to look at slope of the line today and equation of the line. So first, let's have our formula for slope given 2 points. And it is change in y's over change in x's. So subtract, and it comes from 2 points, x1, y1, and x2, y2. I find that it helps to label the points. All right, so our first question gives us the points -4, 4, and 3, 1, and asks us for the slope. So we're just going to label. This will be x1, y1, x2, y2, and we're going to plug in. So we have m equals y2. So 1 minus y1, it's just 4, over 3 minus, you have to be careful here, it is a -4. So this gives us -3 over, this will make plus, so it gives us -3 over 7. Right, next we'll look at problem 2. Same kind of question. They want the slope of the line, and they're giving us 2 points, -1, -7, 3, -5. And so we'll label those. This will be point 1, so x1, y1, and this will be x2, y2. And then we'll write our formula. So m equals change in y's over change in x's, and we'll plug in. So for y2, it will be -5 minus y1 is a -7. Use parentheses so you don't lose a sign there. And x is 3 minus a -1. And then you're going to clean up. So this will make plus. So 7 minus 5 is 2. And this will make plus. 3 plus 1 is 4. And you just need to reduce to 1/2. Good. Right. I'm going to skip 3. It's similar, and look at 4. So again, it's the same kind of question. This one gives you a different kind of line. All right, but we're given 2 points, so we're going to have our formula. Change in y's always goes on top. Change in x's on the denominator. And we can label. So this is x1, y1, x2, y2. And we plug in. So y2 is 0 minus y1 is 0 over x2 -7 minus 3. So we get 0 over -10. 0 is the slope of a horizontal line. So when you have the same coordinates of 0 here, this gives us a horizontal line. Actually, it could be any of the same coordinates here, would be a horizontal line. So horizontal line always has slope equals 0. Good, and we will do number 5. All right, so it's the same idea. Find the slope given 2 points. And just because of our last question, you might notice here, this one has the x's the same. And we'll see what happens there. So x1, y1, x2, y2. Write our formula. So slope is equal to change in y's over change in x's. And we plug in. So we have -10 minus a -2. And this is 6 minus 6. Right? On the numerator, this makes plus, so you end up with -10 plus 2, which is a -8. But your denominator is 0. You're not allowed to have a 0 in a denominator, so this is an undefined slope. And you get that on a vertical line. And your clue that the x's were the same tells you that. So actually I need to pick this second choice. The slope is undefined. Right, and then I'm going to skip a few because these are similar questions, and I'm going to go to problem 8, where we will look at slope from the equation. And we have one form of the equation of the line that's very nice. It is called the slope-intercept form, and it has y isolated. It is y equals mx plus b. Y is all by itself, and your slope will be the coefficient of the x. If there's a sign, it's included. This constant will be your y-intercept, and its coordinates are 0, b. Right, let's look at question 8. They are giving us an equation, and they are asking us to tell the slope. We have to do some algebra on this equation before we can give the slope. We need to isolate the y, and then we can read it off once we're in this form. So we're going to do some manipulation on this. We want y by itself, so we're going to move the x to the other side. So subtract it. And then we have -6y equals 8 minus x. And you're going to divide by -6. Now, if it was just a formula, we would do it under the whole thing on the other side. When it's lines, we go ahead and do it under each piece, because some of it we'll be able to clean up. And so here we have y equals, right, this is negative, and we can reduce it. It has a common factor of 2. 2 will go into 8 4 times, and 2 into 6 will go 3. Be careful on the next piece. You have 2 negatives, which make a plus, and you can pull your coefficient away from the x. So this is 1/6 times x, and now we can read off the slope. Our slope is positive 1/6. Good. All right, we'll do a couple more of these. So we're going to try to get to that form, y equals mx plus b. Oh, I went too fast. And another part. So now they want the y-intercept. Well, the y-intercept from this form is going to be this point, and it is 0b, so it is 0, negative 4/3 is going to be the y-intercept. And it tells us to type it as an ordered pair. Sometimes they just want you to give the negative 4/3, but this one is saying type it as an ordered pair. You can choose it from the template if you want. This one gives an ordered pair. You just switch between your boxes. So I have 0, and then you want to click over here, negative 4/3. Good. So now we'll go to question 9. And this one is giving us a special line, x equals 10. And so we can't really get this in the form y equals mx plus b. So we have to think outside the box a little bit. And remember, when you get just x equals something or just y equals something, it's a special line. If you get stuck and you forget which it is, you could do a little table and graph it. This one is going to be a vertical line. But if we forgot that, we could make a little table and say, okay, I can graph this, but my x always has to be 10, and I can put any y I want. And if we just did a little graph, right, and then it would be 10, 0, 10, 1, 10, 2, and you would see, oh, this is a vertical line. Sorry, I got too far to the edge there. But that would remind you whether it's vertical or horizontal. Only having one variable, that tells you it's one of the two. So this is a vertical line, and you might remember from the other problem a few minutes ago, a vertical line has undefined slope. So we want to choose B there. All right, and they did not ask us for the y-intercept on that one. If they did, it would be this point right here. It would be 10, 0. That would be your, I'm sorry, that's the x-intercept. Y-intercept is parallel to the y-axis, so there's not one. All right, question 10. This one is also a special case because you only have one variable, y equals 18. So we just did one, which was x equals something, and that was a vertical line. So this is going to be a horizontal line when it's y equals something. Right? A horizontal line has slope equals 0. So that's one of your cases to remember. And we're good. Right. So I'm gonna skip this one, or I can do it, and then I'm gonna move to parallel and perpendicular. For this one, you only have one variable. You would need to just do one extra piece on it, and I'll get you started there. You would need to isolate that x. So move the 8, subtract 8 from both sides. So x equals negative 8, and then you would say, oh, this is a vertical line. because it's x equals some constant, and its slope is undefined. But you just had to realize there, do some algebra to make it look right, and then you would be good. All right, so now we're going to talk about parallel and perpendicular lines. Parallel lines have the same slope. Whoops, have. And parallel lines, remember, are the same distance apart forever, like railroad tracks, okay, except straight. All right, that is parallel lines, and they have the same slope. Perpendicular lines have slopes that are negative reciprocals. And so what this means, just a shortcut, is opposite sign and flip them over. Right, and perpendicular lines look like this, like the floor to the wall, have a 90-degree angle. Okay, so those two would be an example of a perpendicular line. Right, and what you need to know for either of those answers, whether it's parallel or perpendicular or neither, is you have to know the slope. So for this one, we have two lines, y equals 6x plus 7 and y equals 6x minus 2, and what they want to know is parallel, perpendicular, or neither. They were being very nice to us here. They gave us the y equals mx plus b form. So we can pick off the slope, which is all we really need to know. These slopes are the same, so this is parallel. Usually they'll make it work more than that. All right, we'll do one. No, I have a few more of those. Sorry. And they just switched these to function notation. This is 13. They put f of x instead of y equals negative 6x plus 6. They put g of x instead of y, 1/6 x plus 2. Same question, parallel, perpendicular, or neither. They are in the proper form. These function things are y. And so mx plus b, mx plus b. Your slope on this one is negative 6. Your slope on this one is 1/6. So they are opposite signs, and you flip them over or take the reciprocal. So these two are perpendicular. Right, and I did do 14 on the list. So I have two lines. I'm going to have to do a lot of work on this one because neither one is in the proper form, the y equals mx plus b, so that we could read off the slope. The fastest one to fix is this one. I can add the y to the other side and move the 3, and that would get me the proper form. So this one becomes, let's see, I said add the y and move the 3. So I'm going to have to subtract the 3. So 5x minus 3 equals y. So y equals mx plus b. It doesn't matter which side it's on, as long as y is isolated. So this slope is 5. But we're going to have to do some more algebra on the other one. Not such a short one. So we want to isolate y. So you're going to move the 10x. So you're going to add a 10x. And over here do it after because they're not like terms. And then you need to divide out your 2 under each piece because it's a line. And 2 into 10 will go evenly. It will go 5 times. So now we can read off the slope. So in both cases, the slope is 5. So these lines are parallel because the slope is the same. All right. I'm going to move now to problem 18. And it says find the slope of a line parallel to the following line. And your f of x is y. So this one is in the proper form, y equals mx plus b. If it's going to be parallel, then our slope would have to be the same. So we want our slope to be negative 1/3. That would be the slope of a line parallel and if they'd said perpendicular, we would have had to take the opposite sign and flip it over. But they said parallel. All right, here's this one with perpendicular. So they're giving us a line, and they say find the slope of a line perpendicular to this line. So this is in the slope-intercept form. Its slope is 3, right? Ours is going to be perpendicular. So we want the opposite sign will be negative, and we flip it over. Our slope will be negative 1/3. That will be perpendicular. All right, 20. So I did choose this one. Same idea, but they're going to make us do algebra first. Find the slope of a line parallel to this line. but this one is not in the proper form. So that's why we have to do some algebra first to find this slope. Ours is going to be the same because it says parallel. So ours will be the same, right? So we need to isolate y. So I'm going to subtract the 7x from both sides. So negative 2y equals 8 minus 7x. Divide everything by negative 2. This will give us y equals negative 4. And here, this makes a positive with 2 negatives, 7/2 x. So our slope is going to be the same because it says parallel. So 7/2 will be the slope. All right, and I picked one more question from this section. And this one, they just want us to find the slope of the line that is perpendicular to this line. So same kind of skills. You just have to know that perpendicular lines have slopes that are negative reciprocals. So find the slope of the line. Perpendicular to this line. So we want to switch it around so that we can read off the slope. We want y equals mx plus b, and then we'll have to work on our slope a little bit. All right, so we're going to subtract the 4x. So we have negative 3y equals 12 minus 4x. Divide everything by negative 3. So we get y equals negative 4. And this was 2 negatives, which will make plus 4/3 x. Now, this slope that we were given is 4/3. Our slope is going to be of a line perpendicular to this. So our slope is going to be opposite sign and flip it over. I'm just going to do the symbol for perpendicular. Will be negative 3/4. Good. All right. I am going to just switch sections for a second to the other section, 3.5. All right. So we should be going now. There are 3 forms of equations of lines that you should know. So you want to memorize these. And to get the equation of any line, you're going to need a point and a slope. So 1 point and the slope. So you might have to find the slope like we were doing in the last section. You know what? I need to see those dots. I thought that I could move that. There we go. I'm going to start with question 2. We'll need a point and a slope. Our formulas for equation of the line, one is point slope formula. Point slope form. And this is y minus y1 equals m times x minus x1. And you need 1 point and a slope to use this form. Your slope goes into the m. Your point goes into the one with the subscripts. You keep the regular y and the regular x. Right? So you need to know that one. Standard form has x and y on the same side. So it is ax plus by equals c. And then slope-intercept form is the y equals mx plus b. So I would put those like on a little index card and look at it often, say your formula out loud, write it down when you do a problem, just to help get them in your memory. All right, so we're going to do question 2, and I'm going to have to get rid of my page there. And it says, find the equation of the line having the given slope. So they're telling us m is 2, and it passes through the point 8, 2. And they are telling us in the directions down here below, type your answer in slope-intercept form. So what we need first is the point slope formula. So we have y minus y1 equals m times x minus x1. And this is going to be x1, y1. And this is m. So we're going to plug in. So keep your regular y. Minus y1 is 2. 2 for m. X minus 8 for x1. All right, and now they want it in slope-intercept form, so we have to isolate the y. So we'll go ahead and distribute over here. So 2x minus 16, and then just move this 2. So we're going to add a 2. Y equals 2x minus 14. That is the form they ask us for. When you type this in, because they ask you to type the equation of the line, they don't give you anything. You have to put the y equals. So y equals 2x minus 14. All right, and we'll skip this one. The ones that are very similar, I'm going to skip. Right, so problem 4. They ask us to find the equation of the line having the given slope and the point. So this time our slope is 3/4. Our point is negative 12/4. They want the equation of the line, and again in blue down here, they say in slope-intercept form. So, but before we can get there, we have to start with that point slope formula. So it is y minus y1 equals m times x minus x1, right? This is x1, y1 in our point. So we have y minus 4 equals 3/4 for m times x minus a negative, which is going to make a plus. Right. What I would do next is I would clear the fraction. You're going to need the 4 over here, but then you're going to have a mess and have to do arithmetic with fractions. So let's clear the fraction out. You do that by multiplying through by the common denominator. So we'll need to multiply every piece by a 4, right? And this is all together. So we just do it at the front. So that gives us 4y minus 16 equals, go ahead and distribute here, 3x plus 36. And now we need to isolate y. So we're going to get rid of the 16, so we're going to add a 16. So we have 4y equals 3x, and these will add together. So 52. And then we divide everything by 4. So we get y equals 3/4 x. You can pull that away from the x a little bit. And I believe this divides evenly. 52 divided by 4 goes 13 times. So there is our equation of the line. And again, we have to put y equals with it. Make sure you get out from under your fraction to put your x. Good. That was 4. So I did pick 5. Find the equation of the line with the given slope containing the given point. So m is -7/10. It contains the point -3, 0. And we will first go to the point slope form. Y minus y1 equals m times x minus x1. And we'll plug in. So this is x1, this is y1. So we have y minus 0 equals m, which is -7/10, times x minus a negative makes +3. Right? And they want slope-intercept form. Well, y minus 0 is y. So we actually have it here. We don't have to clear these fractions, but we will need to distribute. So it's going to give us -7/10x, and -7/10 times 3/1. Nothing reduces for us, so we're going to have to just multiply across. So -21/10. And you could have cleared the fraction if you had chosen to. I knew that we weren't going to have to add or subtract, so that's why I was okay with just distributing. Oops. All right, that was 5. Six. This time they're asking for one extra thing. They want us to go to function notation. To get function notation, first you have to get the slope-intercept form. So you need y isolated, and then you will just replace the y with f of x once it's isolated. All right, they're going to make us work hard on this problem because they did not give us slope. They gave us 2 points, so we're going to have to figure it out. So we're going to need slope. So we'll remember our formula, change in y's over change in x's, and plug in. So y2 is 1 minus y1, which is 3. x2 is 0 minus a negative 1. So minus a negative makes plus. And we'll clean up. So we have negative 2 over 1, which is negative 2. All right, so our information we need is 1 point and a slope. All right, we have the slope. We can use either of the points, and we go through the point-slope form. So it is y minus y1 equals m times x minus x1. And we plug in. So here's our slope, and I'm going to use this point. It would not matter if you use the other point. So I have y minus my y1, which is 3, equals negative 2 times x minus a negative, which makes plus. All right, and we want to isolate the y. So we can go ahead and distribute on this when we don't have any fractions. Negative 2x minus 2. And now we'll add this 3 to both sides. It does have some like terms over there this time. It says y equals negative 2x plus 1. And now we can change to function notation. We had to get this form y isolated first. And now we're just going to switch and put f of x instead of y. And that will get us into the proper form. So this one had a lot of work inside this one problem. And it already has put the f of x, so you just need the rest. All right, that one was 6. I'm going to go to 8 next. All right, and this time they are giving us a graph, and they want the equation of the line in standard form. So I am going to blow this up, and I was hoping to blow it bigger than that. All right, I guess that's as big as it'll go. All right, so what we have now is the picture. We can find our slope by counting from these points that they gave us, or we could get the coordinates and use the formula. I would count since they gave us the picture. Let me get these grids off the top of each other. All right, so we're going to count, start at either one. All right, so if I'm starting here, don't count where you start, count the next one. So I'm moving up 1, 2, 3, 4. So up 4, up is positive. And then I'm going across to get to the other point. 1, 2, 3, 4, 5, 6 spaces. I went to the right, so that will be positive. We can double check. 1, 2, 3, 4 we went up. And 1, 2, 3, 4, 5, 6 we went across. Reduce it. So common factor of 2. Use your calculator if you have a hard time with the fractions. Gives you 2/3. All right, so this is our slope. So we have some of what we need now. We need a point. You can take either one of those where they've marked the point. And so this one is negative 3, 1. And now we have the information to get the line. So we use that point slope form. That's where you always go to start to write your line. Equals m times x minus x1. Plug in. So this will be x1, y1. So we have y minus 1 equals 2/3 times x minus, but it's minus a negative, so it's going to make plus 3. All right. We're going to go to standard form, which they don't want any fractions there. So let's clear this 3 out. We'll multiply 3 by 3. 3, 3, and 3. All right, and that gives us 3y minus 3 equals, distribute here, 2x plus 6. Now, we haven't done a standard form yet. Standard form gets x and y on the same side, constant on the other side, and I always do it so that the x coefficient is positive. All right, so I'm going to keep my x on this side. I need to move the y term over here, and I need to move the 6 to that side. So I'm going to subtract 3y. I'm going to put it at the end because there's no like terms. All right, and I'm going to move the 6 from here to that side. You know what? I'm going to take an extra line to do that. So I have 2x plus 6 minus 3y. So the only thing left to get off now is the 6. So I'm going to subtract the 6. So negative 9 equals 2x minus 3y. This is in standard form. And I will call that SF. So when I enter it, I'm going to put 2x minus y, 3y equals negative 9. It should not really matter. And I didn't click in the box. You always have to click in the box. All right, so 2x minus 3y equals negative 9. Good. So we'll try a few more. Next we have number 9. And this one is a special line. They are giving us slope and they are giving us a point. Whoops, I copied wrong. That should be negative 2. And they want this in standard form. And this one you could plug into your form, y minus y1 equals m times x minus x1. We'll do that. Or you can remember the type of line it is. So I'll show you 2 ways to do this one. So y minus y1 equals m times x minus x1. Well, this is x1, y1. And so this will be y minus a negative 2. So it's going to be y plus 2 equals 0 for m times x minus a negative, which will make plus 4. But 0 times anything gives you 0. So this is going to wipe out. And standard form gets x and y on the same side. Well, we don't have an x, so that's okay. We just need to move the constant to the other side. So move your 2 to the other side. And this is your equation of the line. Now, you could have, because you knew that with a slope of 0, this is a horizontal line. It's a special line. It's only going to have one variable. It's going to be y equals something, and it will be the coordinate out of this point. So it's going to be y equals negative 2. So that actually would get you out of this work for this one. If it was undefined, you would have to go that way because it couldn't plug into the formula. All right. So maybe we'll have one of those also. Good. And I did pick 10. This one, they tell us it's a vertical line. And it goes through this point. And this tells us that slope is undefined. So we have to think outside the box. We can't go the normal way with the point slope formula because we have no m to plug in. So we have to remember that a vertical line is x equals something, and it is going to equal your x value out of your point. And it's done. That's all there is that you can do. So if you're thinking outside the box and you get there, then you're good with that. It's actually a nice question. All right, I have two more. We should be able to get those. So question 11. All right, this one says, find the equation of the line through this point. So we're going to go through this point, and it is parallel to this line. So you have to remember what it is about slopes on parallel lines. Parallel lines have the same slope. So if that one is 2, our slope will also be 2. So we have a point and we have a slope. We're good. So we had to remember some extra information, though, about parallel and perpendicular. So we still go to the point slope form. Y minus y1 equals m times x minus x1. Plug in. So we have y minus 6 equals 2 times x minus 4. Let's see what they ask us for. Write it using function notation. To get to function notation, you have to first go to slope-intercept form, isolate your y. So we're going to move the 6. Let's go ahead and distribute here. We don't have any fractions to clear. So we have 2x minus 8. And now let's move the 6, which gives us y equals 2x minus 2. Now, don't forget they said go to function notation. You just replace the y with f of x. F of x equals 2x minus 2. And they wrote f of x down for you. So we only have to put in the other side. You have to watch always what they have put down to begin with. So if they put nothing, then you would have everything in the box. Good, and one more. I went to question 22. So it looks like I skipped to the last one. Hopefully I didn't mess it up by going this circle. It doesn't look like it's moving, so we'll just move. Question 22. All right. So we have a word problem here. And this says, a rock is dropped from the top of a 2,000-foot building. After 1 second, the rock is traveling 32 feet per second. After 3 seconds, the rock is traveling 36 feet per second. Let y equal the rate of descent and x equal the number of seconds since the rock was dropped. All right, so y equals the rate, which is going to be your slope, and x equals the number of seconds after the rock is dropped. All right. So they say, write a linear equation that relates time x to rate y. All right, and they're giving us a hint to help us get the slope. So we have ordered pairs 132. So after 1 second, it was moving at 32 feet per second. After 3 seconds, it was moving at 96 feet per second. That gives us 2 points, and we can get our slope from there. So just our plain slope is change in y's over change in x's. Right, x1, y1, x2, y2. So we're going to have 96 minus 32 over 3 minus 1. And this will be 2. 96 minus 32. So 64. 64 divided by 2 is 32. So our rate is 32 feet per second. So it says, write all right, the linear equation that relates x to y is given by y equals 32 times x, that's your number of seconds. Normally we would have plus b. Let's see, we started at 2000. So I think that that's what we would have. I think this might need to be a negative 32. We'll put it in like it is and see, because it's falling. That's what makes me think that. So I have the y equals there. Sometimes it's there, sometimes it's not. We'll see if this is right. Okay. So y minus y1. They're saying I should have gone through the point slope form. So y minus y1, 32, equals m, which is also 32, times x minus x1. All right, and this is 32x minus 32. And they want what form? They didn't say which form, but when you add this 32 and get it over here, these are going to cancel. So I should not have put that other number on there. This is all they wanted. And if I had gone through my formula instead of trying to just think it through, that would have been the right thing to do. All right, so y equals 32x. All right, now they're happy with that. After 10 seconds, the rock travels at a rate of. All right, so x is our time. So relates time x to rate y. So we just have to plug in. All right, so after 10 seconds, So we'll have y equals 32 times 10. This will be 320. And this is going to be feet per second will be the rate. So 320 feet per second. All right, so Mrs. H got caught by them. I was thinking I needed to do something with the 2000. I didn't have to. It didn't matter how high that it fell from. All right, I did not need that at all. All right, we'll stop there. You have a lot to memorize from this section, so write those formulas down on a card. That will help. All right, you guys have a great day.